programming languages, other programming environments, and in particular the structure of things. What I mean by the structure of things is that unlike many programming languages, I'm just going to refer to Dart as a language. You'll see later that it's a lot more, but it simplifies things if I talk about it as a language. But unlike many languages, Dart is a company. Dart is a San Francisco-based startup with many of the trappings and needs of a San Francisco-based startup. And that sort of implies a lot about the language. And in particular, what it implies about it is that Dart has a sense of purpose. Many languages have a sense of purpose. Rust, I think, is a very good example of a language which is very specifically built for its niche. And you see similar things with languages like Go and like PHP. And Dart has this similar sense of purpose, and I'll get a little bit into what that is later. But the simple example, or the simple description I'll give, is that Dart is built for removing all of the accidental complexity of building back-end systems. So before I get to that, I'll give you a quick intro of how I personally got to Dart and how this sort of informs the design of the Dart system. There we go. Okay, so a little bit about me. I did a PhD in compilers and static analysis. I'm very into making things faster. I really enjoy the optimization side of things. Turns out that when I was doing my PhD, people were not terribly excited about the optimization side of things. So you'll definitely not have read any of this research. It was not widely received. And in fact, much of it was not widely published, but they give you a PhD anyway. So I was delighted by that. After I did my PhD, I got into Y Combinator, which is a popular and it's like the biggest startup accelerator that companies like Dropbox and that sort of thing have come out of it. And it did not as well for me as it did for Dropbox. This was my company, and this is what happened when my company shut down shortly after. But I learned a lot, and I learned a lot. The primary thing I learned was that I wanted to go back and write some compiler stuff for a while. So I went to Firefox, and I worked on the Firefox JavaScript engine. And after spending a year in Firefox, mostly fighting with the build system, I ended up going and building a build system as a service. Which is a company that now has about 250 people, has sort of 8 figures of revenue, sort of successful-ish in the San Francisco sense. Probably the biggest continuous integration company that is there currently. And it was at Circle CI that I figured out a lot of the things that led to Dart. And the first one of them, possibly the most important one of them, is that it's really hard to build software. If you're trying to do something at any sort of scale, and you're building for any sort of large number of people, then building, in particular back-end systems, in particular cloud systems that have to scale, is a particularly large challenge. And when talking about the sense of purpose that Dart had earlier, the big sense of purpose is that systems, and in particular large-scale systems, are hard to build. And I wrote this essay while I was doing this, which was called "It's the Future." It was pretty well received at the time, and this is sort of the culmination of it, which is I'll just need you to read that for a moment. So the idea basically that systems used to be easier, and they used to be very easy when they didn't have to do anything, but now they have to do a lot. And as a result of that, they have become substantially more difficult over time. And so I wrote about this, and a lot of people agreed with it. It did pretty well on the side of people who hate everything. And so I started thinking about this a lot. I spent I spent quite a number of years actually in between starting this sort of like line of thought and actually to where we are today. Dark is about it's about 2 years old now, and it was started very much intensely for the purpose of getting as quickly as possible to a solution of this accidental complexity. The kind of accidental complexity I'm talking about. Are people familiar with the idea of no silver bullet? Have people read this? Okay, there's a lot of nodding, but actually doesn't matter what you say, but keep going. There was an essay by a guy called Fred Brooks called No Silver Bullet. And the idea of it was that it is not possible to make systems or to make programmers 10 times more productive. Because in order to remove, or in order to make developers 10 times more productive, you would have to remove 90% of what they do by definition. And his argument in 1986 was that 90% of what we do was not what he termed accidental complexity. And accidental complexity is the stuff that you don't need, as opposed to essential complexity, which is the stuff that you really, really do need. Your business logic, the thing that you're building, your reason for being in business or for writing this piece of software is essential complexity, and everything else is accidental. And if we could remove all of the accidental complexity, how much faster would we be? But his claim was that you couldn't be 10x faster. And our claim today is actually that you could be 10x faster, because the accidental complexity has grown so much in the 30 years since Fred Brooks wrote this paper that it is so big that if you removed it, you would get a 10x increase. And in fact, we see accidental complexity absolutely everywhere. And one of the things in building back-end systems is that the amount of technologies, or the number of technologies that you need to learn, is absolutely out of control. So the kind of things that you need to learn in order to build a scalable, resilient system for your customers, you need to know things like Kubernetes and Docker. You need to know all the development tools, things like Git. You need to know about load balancers, dozens of different AWS services, SQL, NoSQL, Kafka, Unix, gRPC, GraphQL. I could keep listing things, and my list actually continues on quite a distance. We'll stop there. And Dark, it's been a struggle to describe Dark at times, because Dark is about removing the accident. It's not about anything else. It's not about something special about the language. We didn't set out to design some kind of language, or to design some kind of environment, or something that's live in any way. All of that came out of this idea of how is it that we could possibly remove all of this accidental complexity. And there's basically three kinds of accidental complexity that we're trying to remove. The infrastructure complexity, which I've just been talking about, all those systems that we need in order to actually have the back end. But then the second one is deployment complexity. And deployment complexity is something I'm very familiar with from Circle CI, and I'll talk about that in a bit. And then API complexity. It used to be, once upon a time, that calling functions was pretty easy. You would just like link in the library and call the function. And that's not really true anymore. So the infrastructure complexity looks a little bit like this. This is the Cloud Native Computing Foundation landscape. So it's a list of all of the Cloud Native Computing Foundation's projects that do basically anything that does something with Kubernetes is in this list. So if you're building something in the Kubernetes world, which a lot of people are for how they build their systems, there are 455 different technologies that you might want to use in order to build your system. And it says right at the top here, you might be hard to see from the distance, but it says overwhelmed ? Yes, indeed, we are all overwhelmed by this, because the only thing that you actually need to build a backend system, the essential complexity of the system, is very, very simple things. You need to receive data, you need to process data, you need to store and query that data, and you need to send it. And you can think of this in terms of a website very simply. You make a HTTP request to it, you execute some things, you store something in a database, and you send a HTTP response. And that's kind of the entire complexity, the entire essential complexity of a distributed system. But instead, we end up with this sort of thing as being the code that we actually need to write is all to deal with this, and that's what we're trying to get rid of. This here is a CI/CD pipeline, a continuous integration / continuous deployment / continuous delivery pipeline. So the way that engineers deploy software to production as part of their teams. So I'm wondering actually, I don't know the mix of academic versus non-academic. Can you raise your hand if you have deployed a production system using something that roughly looks like this? Okay, so about half. So I'll go into it a little bit more. So the idea, if you're on a software team, is that you push code to Git, and then at some point there is a process which takes the code that you push to Git and gets it into a server on the internet. And the process is, you actually write the code, you make a branch at Git, you make some changes, you run some tests, you make a pull request. And then you get some code review, and then you run all the tests again, but on a different server this time, not your machine. And then it all goes into, it gets repeated again when it gets merged to the master branch. And then it gets built into a container, a sort of a Docker container. The front end stuff gets pushed to a content delivery network, and the container makes its way into Kubernetes, the thing that we all use apparently to run our infrastructure. Kubernetes slowly gets this out to the world. Many of them exist, and they slowly get rolled over with the new code. And then this is kind of the key thing about Dark, so we'll go into it a little bit more. But people have stopped using code as the unit of deployment. It's no longer the case that when you ship a piece of code, it replaces the old code, and that is our unit of deployment. So it's not the case that if we have a feature that's going live at 9 a.m. that we press the button at 8:55 and hope that it arrives at the same time. What people have started using is using feature flags, which I'll talk about later, but are basically a glorified if statement. An if statement that you can control from somewhere else so that you can enable a particular feature for a subset of people, or for your whole audience at a thing that you can control. So this is, if you're familiar with A/B testing or Facebook doing experiments on you, very much the same sort of content that we use for that. And so this is how people ship the feature. They actually enable it for first 10%, then 50%, then 100% of feature people. And then once it is deployed to 100% of people, the feature is fully done. And then we need to go back the whole way to the start to remove the feature flag and the code and everything that goes with that. And so Dark is about, this is the CI/CD complexity that we're trying to remove. And then finally, I talked about APIs are hard, functions are easy to think of, but today to call a function, if you're using a third-party service, which many of these applications are written using, in order to actually call an API, you need to call a different system. You need to make a remote procedure call using some kind of probably HTTP call, and that you have to deal with error handling, you have to deal with auth, you have to deal with retries and backoffs and all this sort of things that make calling these systems much harder than it used to be. Right? The entire essential complexity of an API is the function call that you want to make, the RPC that you want to make, but the actual practice of how you do it is much more complicated than that. Okay, so we came up with Dark as a solution to solve this. And the easiest thing to show you Dark is I'm going to show you a video that my co-vendor made that's about 8 minutes long. And if you prefer to read things instead of watching the video, this is the URL, darkline.com/launch/demo-blog. And give me 1 second to take it down. All right. And then let's see if we can play this video. Yeah, that's my co-vendor Colin. Okay. And oh.
co-founder of Dark.
Everyone
And
able to
I'm excited to show you the holistic programming language, editor, and infrastructure we've been working on for the last 2 years. Today, I'm going to show you how to build a fully functional backend for an Office sign-in application. But first, I wanted to do the first thing I would do in any language, which is set up a hello world. And Dark, you don't have to install a bunch of stuff, particularly with infrastructure, before you can have a working API. In fact, all I need to do is specify my route, the method, and my response. I now have this as a JSON API that's on the internet and available. I can say add a URL parameter to it. So I have hello name, so I can greet my guests by name. And if I were to do this, I can say hello to myself, say hello to my co-founder Paul, say hello to everyone else who works here, say hello to you and developers watching this video. In Dart, I now can see all of these pull requests, and I can see what the expression evaluates to. If I chose to change a piece of it, I can see what that trace would now evaluate to. So that's how you get started with Dart. But let's get into building a full backend with, say, workers and API integrations and all your usual backend things. Ahead of time, we built this React application. It's the front end for our Office sign-in application. The only thing that's special about it is that it's pointed at Dart's API for the backend. Otherwise, Dart is completely front-end agnostic. Use React, Vue, Svelte, any tool of your choice. I previously built this application in my terminal, npm run build, probably looks pretty familiar. And now I'm going to use Dart's command line application to upload my build file into our CDN. So now that those assets are available for me, what I can do is I can just serve them at whatever route I want, in this case, just the base one. And I need the index.html. So there we go, React application. Right now we're getting a 404, but we don't have our API yet, so let's do that. Traditionally, I would use my browser tools to inspect, check my console. In Dart, I don't need to do that. I can actually get in real time what request is failing and create that endpoint. I can throw some data in there quickly, and there we go. Alan and Paul are our hosts. But that's not what you want for a real app. So let's create a new data store. I'm going to make one named hosts, and we're going to give our hosts names, obviously, and then let's give them phone numbers so we can text them, and Slack IDs so we can send DMs. We're going to want to test this out, so I'm going to quickly add myself into the data store. I'm going to use a REPL because I don't have a front-end built for this in advance, but I'm going to leave myself a note that if I wanted to in the future, I can change to HTTP. We do name our REPLs after a combination of an adjective and an animal, or you can just rename them. So I feel like it's nicer to have that one named add host. And that's not a very clear comment. Change to HTTP later. Great. Okay, so now let's just add me into our data store. You already know that my name is Ellen. I pulled my phone number out into a function ahead of time, and for my Slack ID, I can just grab that quickly from my profile. Since Dart's data stores are key value based, I want to have a unique identifier, and my Slack ID is a good option since no two people that work here are going to have that. So I'm going to extract that into a variable. And then you can see as I'm naming my variable, it's putting it into the place where it was before as well. So there we go. We'll use my Slack ID as a key. That's how we do that. And our host table. Before you saw that we could see the output of expressions, but since our data store functionality has side effects, it doesn't run automatically. We can choose to run it, which I'm going to do now. Once we run it, we see the record that we get back, and we can also see that our host data store is locked. Once we have production data in here, we have to do a migration in order to change our schema. Last piece of this is let's get our host from our data store instead of our dummy data. And you can see we get this preview of our schema in case we've forgotten what field we're looking for. In this case, it's name. Great. So when I go back to my React application, it should just be me. Great, it's me. And developer, if you're here to visit me. We get 404 again, same workflow, we can create a new endpoint. In this case, the difference is that while we're still going to do the same DB set operation that we had before, instead of having to build a full object, we can actually just use our incoming request. Use our request.body. Since we don't have a good unique identifier, we're just going to generate a key, and let's make our new data store. Now host. And it's going to have a visitor. There we go back and fill that in. So now when we go back to our front end, what we're expecting is if we check in, we will have it stored in our data store, but we haven't done anything else yet. So there we go. We get our confirmation and our data store is locked. All right, now let's go about sending me a text message and the Slack DM sitting here. I'm going to use Dark's built-in eventing functionality. So I'm going to emit our request app body. So same as before, that event to send a text. And I'm going to write similar logic to do the same thing, but to send a DM. Let's run both of those. And you can see here, we've created these work items for ourselves. So now we're going to have a new worker for sending a text. Events work very similarly to incoming requests. In this case, I'm going to say let our host name equal our event dot host. And then let's get our host back out of our data store. And let's just make sure we get a response. We do. And the thing we really care about is our host code. And let's write our message, which would be event.visitor is here to see you. Great. So now I think we have everything we're going to need. And let's use Twilio as our next message. In Dark, we wrap the Twilio API. So when I type Twilio, I get this Twilio send text function. It shows me all the parameters I need to call into this API. And so I pulled out my credentials ahead of time. So I need my SID, my token, and my phone number. My two numbers is going to be my host phone, and my body is going to be my message. Like we saw before with our database operations, we can choose to execute this API call. We can see that we get an OK response, confirmation, and I actually got a text message. Great. So one thing left to do. Let's build our Slack DM sitting thing. So we're going to make our new worker, and it's pretty similar. Let's grab our host name again, so we're going to need to get their Slack ID. And direct copy paste works by expression. So we're just going to go around this. Thanks, Siri. Not very necessary. And
my pleasure, as always.
now we're going to get our channel, which is going to be our host.slack ID. And let's just check real quick. Yep, there we go. Okay, so now since we're using the Slack API, we are going to want to pass in a header that both specifies our content type and also our auth credentials. So let's get going on that. First part, Slack needs a bearer token, and you probably already guessed it, we'll let my token in advance. And let's merge that with our JSON content type. And just for ease of use, the URL we're going to be using for the Slack API is their chat API. It's specifically going to post a message. All right, so now we're pretty much there. I'm going to use the built-in HTTP client library to post our URL we've specified. In our body, we need our token, which is our Slack token. We need our channel, which we have pulled out as our channel. And we need our text, which I didn't pull it out nicely this time, so we'll do event.visitor. It's here to see you. We don't need a query, so I'm just going to make an empty object, and then we have our header. So let's try this. Do our play button again. Dot message and message. So I think now what we should have is an application where when we go to our front end, we're able to specify who we're checking in to see. We can add more people to our data store. Right now we just have me. When we check in as developer 3, should get stored in our data store. I should get a Slack and a text. And that's how you build a complete functional backend in Dart for something like an office sign-in application in less than 10 minutes. If you're excited about this or have something similar to build, please join us at darklight.com.
Thank you. So that's the thing we've spent about 2 years building. I'm going to talk a lot about this and a lot about what led to this and so on, but this is probably a good place to pause for questions about what was in the video. So if you have questions or even just things you want me to hit on as I'm talking about other things, there's a good spot. There will be lots of questions later as well if you haven't got your questions together right now.
Sorry if you already mentioned it because I came a little bit late. Just what is the inspiration for the language, what is the syntax that we are seeing, and what is the nature of the live context that while you are programming the backend. I saw that you have some kind of trace of the message that had been sent before,
Right.
or is it a live context of the execution, like you would have in a debugger, for example?
Okay, so your first question about the language, I'll come to later. The traces I talk a little bit about, but just to talk about what we're actually seeing in the video. The traces are recorded when you make a request. So when a user makes a request, we save a trace, and we save that trace for the particular HTTP handler, and then anywhere that's propagated to functions and to event handlers and that kind of thing, we propagate the trace to there as well. And then we embed the interpreter, we embed into the editor, so that as you make an edit, we will show you what the value would be if that code had existed when that trace was created. And then it was probably a little hard to see. There's a little green play button that John used to execute things. Anytime that you execute something, that gets saved in the trace as well. And then the whole thing is a multi-user environment, so the traces are all shared between different people who are editing in this environment as well. So everyone gets to share in the traces.
Are you going to tell us something more about the editing experience that we saw?
Yes, we'll be back to the editing experience. In fact, we'll be back to the new editing experience because this one sucks. Ellen makes it look easy, but no one else does. Cool. Anything else we want?
Okay, so Mark, do you have a list of programming language buzzwords that standard descriptions? What kind of language is this?
So I will be getting to that, but functional/imperative. There are everything looks functional, but then you're doing impure things. But one thing about it actually is that we've encoded purity into the language, so every function is marked as whether it's pure or impure. And this is part of what allows us to do this this live update of everything. We automatically calculate the pure stuff in the client, and the impure stuff is only calculated on the server.
You calling to another language directly from Dart, or would you have?
There's no other languages. You're in fact, good segue into the next section. So Dart is a holistic language editor infrastructure, and part of what that means is that it is united and integrated, and it is all the same thing. But part of it also means that you can't use anything else. So you must use the Dart language, you must use the Dart editor, you can't use Vim or Atom or Emacs, and also you must use the Dart infrastructure. You can't run this yourself, you can't install it yourself. The infrastructure runs in the Dart cloud as it was, and there are no alternatives to this. There's a question of
Yeah, 30 years ago, this was called a 4GL.
Yes, we were just talking actually before the thing about 4GL and
40 years ago, this was small.
Yeah,
So small talk is a comparison that we get a lot. 4GL is that's been rebranded no code or low code.
Yeah, I know. Yeah, but that's
the investors are throwing money at it. We are actually trying to separate ourselves from low code a little bit. We're trying to refer to ourselves as sort of high code. And part of our context for this is that we believe that the low code stuff tends to be some sort of like wizard or WYSIWYG or something like that, where once you reach the edge of the abstraction, you're kind of done. There's no more wizard, and there's no way to combine them. The idea of us using a programming language for this and having a programming language, partially it's because we believe our go-to-market is developer first, and this is how this sort of thing gets adopted. But also a lot of it is that when you reach the edge of an abstraction in code, there's just more code below and there's more code above it. So you can combine things, compose them, reuse them in a way with code that you have with non-code through the side. So basically, we built an abstraction over the cloud. And in fact, if you read our investor memo, we talk about how we are replacing AWS and replacing it with a programming language, which is a sort of a weird concept, but it's really just about abstraction. The abstraction that we present to users is the programming language, but really what you get out of it is the ability to build cloud applications. And then as a business, we run the cloud applications and sell you infrastructure in the same way that AWS or Google Cloud or Azure or whoever else sells infrastructure. So talk a little bit about a little bit about the stuff that's in it. So I'm going to go briefly into the infrastructure, the underlying language, and then we're going to talk about the things that make it possible and the things that come from the fact that it's all integrated together, which are what we refer to as the live values, which is going to be extremely interesting to people in this room, and also deployments, which is another way, another sort of axis of liveness. So this is roughly what Dark looks like. This is if anyone's done a coding interview in the last 10 years, this might look familiar. But it's vaguely functional. There's list map. Here's a lambda here, and everything else just looks like it does kind of in a normal programming language, except that there's no assignments. It's expression evaluation, as you see sort of here. But the idea is Dark looks like a normal program. It's super straightforward if you have experience with the sort of paradigm. And then this is how programs look in Dark. You've seen that a little bit, but there's an API endpoint. There's a URL for it. There's what method there is, and then there's just a whole bunch of code with ifs and whatever else. Dark is not a particularly mature language, so there isn't a whole lot of ways of making this super nice and elegant. So you end up with a lot of boilerplate repeat code, which is something we intend to address in the future. This is also Element code, which is more simple than most code. And basically with this thing, what you're doing is the thing that you do repeatedly, which is you take a request, you have request.body here, you do some sort of processing on it, and then you set something in a database. And that's kind of what we do repeatedly and constantly. And the units of this of the essential complexity I was talking about earlier, the things in Dark that allow you to have that essential complexity for infrastructure. There's data stores, there's cron jobs, so scheduled jobs, there's workers, so background workers, and then there's HTTP handlers. And these things we call them a REPL. It's not a real REPL, but it's a tool that you can reuse. We refer to it as REPL as the simplest analogy in the non-Dark world. But these are the essential complexities of building backend systems. You need to have something that the HTTP client talks to. You need to be able to run something in the background, and you need a place to store data. And so this, we believe, is the smallest unit of things that we can do without having to incorporate things like front-end clients or mobile clients or that kind of thing. We think of Dark, the edge of the abstraction is the API. You build APIs in Dark, and so these are the building blocks of APIs. So this is the editor, and you'll see a little bit. This is our new editor. This is the one that Ellen was talking about, but I'll talk about that for a second. So what we're doing here is we're just typing, and our new fluid editor is something that allows you to type without it really feeling like a sort of form, which is what the old thing looks a little bit like. And then when you're done with it, you backspace through the whole thing, and things. Backspace is a thing that exists. So the idea is that this feels textual. Let me talk about a little bit about how we got here. So one of the key ideas about Dark is that there's no editor, and because there's no editor, there isn't the need for there to be text. So Dark is an AST-based language. The editor directly edits the AST, the abstract syntax tree. And our first version of it, well, our second version of it, we don't talk about the first version. But the version that you saw in Ellen's video, which she makes look extremely fluid and simple, is sort of like you're filling in a form repeatedly. So if you want an if statement, you type if and you press enter and you get an if statement out of it. And you sort of tab between blanks that need to be filled in, and it feels extremely formless. And it had all sorts of problems, like if you were in field access, you'd press a period, and then you would be unable to backspace that. sort of just myriad bugs, but really the problem was that the paradigm was sort of shifted. And we looked at a bunch of other editors, things like Sketch and Sketch, Hazel, Landu, other similar things, and we came up with this idea, sort of the same idea that they have, that everything should feel like text. And when we talked to users about this, they felt, yeah, I need something that feels a lot more like my text editor, or as it was really expressed to us, why do I have to use your shitty editor? Why can't I just use it? Or Emacs sometimes. So we designed this new editor around the idea that everything is text. There's a cursor, and at every point that your cursor exists, there is something that can happen if you press a key. Sometimes it will be swallowed if you press something that doesn't make any sense. But that the main things that you're doing are that you're typing or you're reading. And we ended up with something that's pretty nice. If you're interested, we can play with that a little bit more later, or you come up to me afterwards and we can play it first.
So this is the parser with text.
This is the second one of them. So
Okay,
there's no parser. It is projectional from the AST, and there's actually kind of an interesting. We went through a couple of different iterations of how it works, but the way that it works is sort of as a reverse parser. So we have the AST. The AST converts into a set of tokens, and then the browser displays a bunch of these tokens, and then each keystroke is associated with a particular token, and then the token goes back to make the change to the AST. So it feels a little bit like the opposite of sort of tokenization and sort of the parsing step, and is actually conceptually pretty easy to do. It ends up being our editor is about 4,000 lines at the moment, so it's actually much more complicated than the part of the system. But it's relatively easy to add to it. All right, so the programming language. It is a functional imperative hybrid. Whatever that means. Basically, it means that it looks like a functional language and it is statically typed, although we're sort of lying about that. I'll get to that in a minute. But we want you to think of it imperatively. So our theory is that people can reason about imperative things a lot better than they can reason about something like Haskell. And our experience of using Dart is written in OCaml, which is a sort of functional imperative hybrid as well. And so we had a lot of influence from OCaml. And a little bit from Rust, a little bit from a couple of other languages, Swift, TypeScript, Clojure, and in particular Elm, which is a language that isn't particularly well known, but is a really beautiful language that we copied a lot of the concepts from, even though it itself is just a cut down of Camel. So basically, we are trying to make it functional, but we are trying not to be dogmatic about it. But there's some interesting things about it. So we use records and enums. Rather than using like object orientation, that kind of thing. We felt that object orientation contributes to people not really understanding things because we're trying to model, what is a car instead of trying to actually write what your thing is. We have no null. That's also a lie. We have options and somehow null stuck in there. I'll talk about that in a sec. We have results instead of exceptions. Also a lie. We have static types, and we have imperative statements and refs, and then it is garbage collected. The only thing on this slide that is completely true is that it's garbage collected. And what I mean by that is this goes back to what I was saying earlier about Dart being a startup. We have cut scope massively. So the version of Dart that we see today is not the version of Dart that it is going to be. It is what is the simplest, and in some cases, shittiest thing that is good enough to get to market and is good enough to allow people to build applications with. So people who use Dart honestly, truly believe almost everything in this. This one, there's absolutely no support of. So this one is a straight line. It's a directional place that we will be going in the future. But everyone believes that there's static types. There's actually no static types. There's a dynamic type checker. And there's an autocomplete which uses types. And so between the two of them, it ends up being that people write things that are statically typed the first time, and that it ends up working. And it's sort of really weird, but we ended up not actually having to write a type checker. Yeah, we will write one. I promise it'll be fancy. Hopefully. Enums we just didn't implement apart from the ones that we need for results and options. People need that, but you can sort of replicate it with records, so it ends up being fine. New versions of the language will have enums, and then something else here that's sort of like immutable values is also true. And we used immutable values because we felt that simplifies how you think about programs, and it also allows this live thing that we're talking about. We don't need to save the value at every single point. We just because there's immutable values, we know that we're going to be able to recalculate everything as we go, and that we're not going to be relied on some shared state that is deep in some call stack somewhere. People have questions about this. Have I answered people's questions? Do people have more questions about the language? Questions about the language, okay.
Actually, I have a question about the editor. So given that, right, it seems like the key thing is sort of abstracting something like AWS programming language. And given that you're a startup, why do you find it like so necessary to invest so much time into the editor rather than like I guess just sticking with the text editor and calling it a
Were people able to hear that, or should I repeat it? Raise your hand if I should repeat it. Okay. So the question was, as a startup, why did we invest so much time into all of this stuff when we could have just used existing text editor and that kind of thing? And so our premise was that all of this accidental complexity came from the fact that everyone was building incremental tools. So people are building text editors. The text editor doesn't know anything about the programming language, and the programming language doesn't know anything about the infrastructure that it's run on. Programming language just knows that it's going to run on a computer, but it doesn't know that it's going to run in the cloud. So we're trying to build cloud stuff out of stuff that runs on computers that are built up of text files that are written in like inodes and all this like complicated stuff. And so much of that of this intersection introduces complexity. So it introduces like version control complexity. We need Git, and we need Git because Git works on any text thing, and it has diff algorithms that work nicely on sort of any text thing. And Dart doesn't need diff algorithms. It doesn't need a version control that has files that can share with a sync server and that work on GitHub and that sort of thing. It massively lowers the overall scope of what we're doing, which also massively lowers the number of concepts that people writing code in Dart need to understand or need to interact with on a daily basis. And I think in terms of removing this the CI/CD thing, which is the key thing, would not have been possible if you could use it in your text editor. Because if you write code in your text editor, then you need a way to get it into production. You need a step that goes from the code that is on your machine into production. And what we have in Dart is that you write in the browser, every keystroke is synced to the server. The sync is a very, very small AST update that gets sent to the server. It gets transacted immediately into a database. And so the deployment time is, we refer to it as 50 milliseconds. That's only because people didn't like the idea of live coding in production, which was our initial pitch. So now we deploy in 50 milliseconds. Yes, does that sort of answer? Roundabout way.
If I wanted to extend that language in order to express certain kinds of application logic that happens in the processing step, could I do that?
Could you extend the language? You could write libraries in the language.
No, that's not the question.
Yeah, no. So you can't make a version of Dart that is different. Yeah. We are interested in adding macros. We have not added macros, and so maybe a little bit you may be able to extend it in some ways. But, there's another question up front here.
So far we've seen the handlers and the database, but
yes.
How would you, in this editor and in the language, kind of express application logic? I mean, for example, building a library.
So how would you express application logic? Building a library. I'm not getting the question exactly.
So if you have 5 handlers which all do the same thing,
yes,
in a variety, yeah, then you would extract
that out. I understand. How do you extract things into functions, that kind of thing? Yes. So what I showed you was what we refer to as the structural elements of Dart. And the other part of code that you write is what we call non-structural elements. The things that matter, the things that you think of in your infrastructure are those structural things. And the other things that are in your call stack, notably functions, libraries, packages, types, they sort of exist to the side somewhere. And you can access them, but we don't think of them as the architecture. So that's why we did focus on them. But they exist. At the back.
How do you deal with stream processing, or do you have arrays, or do you have collections? Because I can see that you can have options, which would be 0 or 1. You also have many language.
So the question is, do we have, I think, strings? Strings or strings?
No, arrays or stream processing, streams or something like
do we
that.
have arrays, lists, collections? Yes, we have sets, we have dictionaries. Actually, we don't have sets. We have dictionaries, we have lists. Lists and arrays we intend to make them the same thing, which may horrify the functional language purists or the lispers in the room, but the intent is that we unify the interface, that we choose the optimized version first, but basically there's only one version of those. And then there's dictionaries. We will add other things as well. So if you want a nicely balanced red-black tree, there will be one at some point in the standard library, but none of that exists. Okay. So that's kind of the three things: the editor, the infrastructure, the language. And the things that are actually interesting about Dart are none of those. We deliberately pick stuff that already exists. And so the editor maybe is slightly new, but even then we copy a lot of people. But the ideas were deliberately simple and copied. Because everything interesting in Dart is at the intersection of these things. The phrase we use is innovate at the boundaries, so the boundary of the editor and the language and the infrastructure. And either at the intersection of two of these, or the better stuff comes at the intersection of the three of these. And when you think about a lot of the advances that have been made in how we write basically in cool shit that we do in developer tools, a lot of them happen at the intersection. So if you think about Brett Victor's work, if you think about Eve, this stuff tends to happen at the intersection of the language and the editor in particular. Or if you think about the cool stuff that you get out of if anyone writes front ends, there's a lot of cool stuff that happens at that sort of intersection as well. And that's the kind of thing that we're trying to do, and that's where we got a lot of cool stuff. And the major cool thing is this deploy list thing, the coding live in production, deploying in 50 milliseconds. The overall term that we're using for this is deploy list, which is a term that honestly we would be embarrassed about, but someone else pointed they were a bit famous, so we went with it. And deploy list is intended to be a little bit like serverless, in the sense that in serverless there are servers still, but you don't have to think about them. And in deploy list, there is a deploy, but you don't have to think about the deploy. And basically, what we mean by deploy list is there's always an instant deployment, and in particular, there is no deployment step. So it is not that you are pressing save. It's not that you're clicking on the button in your editor or doing the keystroke. Whenever you type something, it is already deployed into production. And this is kind of the thing that is key for Dart, and it's probably the most interesting thing for you folks. And then the other half of that is that we made it safe for this to happen. So it's not like people were writing PHP in the 90s where you're using VI on the server, and that when you edit things, there are requests that are coming in live, and then they get parse errors and that sort of thing. It's very much designed around how can we make this instant deployment safe. And this is primarily around the accidental complexity of that CI/CD thing. If it takes 32 steps and 3 loops to get code into production, then inherently it is going to take a significant amount of time. And maybe that time is super optimized and you have it down to like 5 minutes or 10 minutes or something like that. Or maybe it's not that optimized and it takes you an hour to get code into production. When we thought about that process, we thought about what is the lowest amount of time that it could possibly take. And that is 0 seconds or 50 milliseconds, depending on how we position it. And so this was very much a very, very deliberate thing that we're designing from the sorry, first version of Dart had what we're referring to as the flows. And I'm going to show you roughly how we make it safe here. And it's using feature flags, but this is a demo from, or this is how the HTTP handler ended at the end of Ellen's demo. So it's got an emit, which sends an event to a background handler. So it's got the send text background handler, which sends the SMS, and the send DM, which sends the Slack thing. And what we are doing with it is we're going to add another one to it. So we create a feature flag. You can see the feature flag here, the little flag in the indicator, and then the feature flag is sort of like a Git branch. It's an if statement, but we condense the ideas of a deployment and a Git branch and a feature flag into a single concept. And so basically, you give it a name, you give it a condition, and then you give it the alternative code. And this is what it looks like once it's filled in. So if this particular header is set, then we'll run the new code, and the new code has a new line of code. We've just edited this. This is because no users see this, we can just write it basically freeform. And then once we decide that we want to set this for everyone, there's a little play button here, or a little checkbox here. So once we check the box, and now we have replaced the old version of code with the new version of code. And at every point during the life cycle of this new code being written, the code was completely safe for users. Nothing was broken. Every end user had their application continue to work.
What's your multi-user story? Is there actually a branch that isolates me from these changes on the same program at the same time?
Question is, what is the multi-user story? So it's a Google Docs-like collaboration model. So you see the feature flags that other people create. We do not have customers who have more than 3 or 4 users, so we actually don't know how that scales. Yeah. But we imagine that we will be able to make it work. 5 minutes. All right. Okay, so I'm going to skip some of this stuff because we're down to about 5 minutes. The other thing that's super interesting about Dart is that we version everything. So we version all the functions in the standard library. We version the language itself. We version databases, and this is part of what allows that to safely transition from one version of something to another. So if you want to change a function, you don't actually change the function. You feature flags the thing that calls the function. You make a new version of the function, and then you switch over to it atomically. So then you're able to very finely define the change that you want to make across your system. And then this is the line values. So I talked a little bit about the traces earlier. So you can see here, these are the traces down the side. This is the live value for this value here, so the request.body. And what we do is we allow you to put the cursor anywhere, and wherever you put the cursor, we show you the value in that trace. If you change the code, we show you what the code would be for that trace. If you go into a function that is called from here, we will show you the function, we will show you that same trace running through that function. And so the thing that we found about this is that it allows much more than we really expected it to. So we thought, oh, this would be a nice feature, or people will be able to understand this easily. But it actually means that people who are learning Dart for the first time and just don't know what the language does, they're able to learn the language really easily. It also means that if you're trying to learn a new piece of code that you haven't seen before, then you can go and you can click on anything and you can know, oh, this thing that's called user, you might not know, is a user object? Is it a user name? Is it a user ID? Is it what specifically is the user? And in Dart, you can just click on the thing and you immediately figure out what the user is. And the other thing that it replaces is the debugger. So you would typically have a stop the world debugger where you need to get some sort of input and then run your way through it again. This feature also replaces the debugger. You just click on the particular trace that you're worried about, and you click on the value, and you sort of get to step through the entire program without actually having to do the stepping through of the entire program. Okay, so I am going to to stop there, and I guess we probably have about 2 minutes for questions or so. Make it good.
Will you be bootstrapping Dark?
Will we be bootstrapping Dark? Really good question. So we have built some amounts of Dark in Dark. So things like password reset flow, some user stuff, some onboarding things, and our collaboration thing are all built in Dark. It's less than we intended to build in Dark. We actually thought that we would run a separate instance of Dark and then build our instance of Dark on top of the second instance of Dark, but it ended up being a bit more of a challenge than we wanted. We may still go in that direction, but right now we're just trying to build as much as we can within Dark, and everything else is written.
What if you sort of switch? You had this feature where you have a feature flag and you sort of commit it that you are down and it replaces it in production.
Yeah.
What if there's a series of API calls and it happens in the sequence? So like the client already called a couple of calls, has some expectations regarding behavior, and then it continues, but it just happened that at that point you flip the flag. Is that a problem?
So the question is, if you change the API when your client is expecting has some expectations around the shape of the API, what happens? And really, what we're trying to do with feature flags is to allow you features to seamlessly make that transition for your users. So in the example we had there, you added or you used a request header to tell whether you should show it or not. And it's really up to the developer to understand what's actually happening in their clients and whether or not it is safe to make this transition. We don't do magic, right?
Yeah, of course.
We're trying to expose the sort of building blocks.
Right. How do tests fit into the picture? I suppose they have to do with something with the execution traces.
So how do tests fit in? Yes, they have something to do with execution traces, or they would if we had built them, which we will at some point, and they will be like execution traces. The intent is that you can take an execution trace, copy it, that you can edit it, and we also hope to have some sort of quick check-like thing where you give it a type and we'll figure out if there's any problems with that.
So is there a UI for seeing diffs and stuff like that? So that in this version.
Is there a UI for seeing diffs? There is not. There will be.
So a question from the Smalltalk perspective. So you have a persistent state of the system, including data and behavior. And I really enjoy that, but every time I discuss it with someone, they always get a little bit nervous because they have the feeling they can't restart. They can't get into a clean state by just throwing everything away and starting anew. Do people worry about that?
So the question is, in Smalltalk, you couldn't restart. In Dark, you also can't restart. And that's a very deliberate feature because in cloud systems, no one can restart. Everything is in some sort of state, whether you like it or not. And if you have to, having gone through a thing where we turned off all of the servers and then had to turn them back on again for a security thing, it's a complete nightmare. It's not really possible, except by very careful user handholding or developer handholding at the right time. So it is very intentional that you always know the state of your system, and that we think of this as a positive distinction from how people write software today, which is there's a bunch of migrations that you store on the disk and none of them actually ever run.
So you embrace basically
the
domain.
That is a good way of putting it, yes.
We can keep taking questions while the next speaker sets up since we started a few minutes late.
Okay. We have a minute or two, so let's make it good.
Yeah.
Who's your ideal customer?
Our ideal customer we have two sets of ideal customers. First, front-end web developers. So people who don't know how to write backends, or they know how to code, but they don't know how to build backends. And then the other customer is people building new microservices within existing microservice-based architectures. And what we mean by that is you're building, you have a product that does a whole lot of things and has quite a lot of traffic or whatever, and you want to create a new thing within that speaks HTTP to the rest of it. And the reason for that is those people will make us money.
So professional programmers, but not necessarily back-end.
Very much
developers.
professional purpose. Everything in our positioning is a professional purpose. Here, and very deliberate choices. Cool. Sounds like we're done. Thank you.
All right, well, I'd like to thank hope to see an update. Next speaker is Yar. Who is been working on Lambu, has been at Live at least once or maybe twice before, and is going to talk about steady typing. Is your time?
Yeah.
Thank you.
All right. I'm going to assume that some of you are not familiar with Lambu. Lambu is also a holistic programming language, which by that I mean that the language and the editor are designed in unison to give an experience that you can't achieve with text-based language. And if you've been in last year, we presented the live programming aspects and why Lambu is based on a functional paradigm. This time, I want to discuss types, and specifically our UX for types. And I want to kind of discuss the pros and cons of different approaches to types, like dynamic typing and static typing and type inference. But there's a small problem with that, which basically a lot of programmers get really attached to whatever approach which has become their favorite. You know, maybe someone learned Java, maybe they switched to Python, and that was an enlightenment for them, and they say they don't like is the best. Maybe someone else had a really bad experience without static types and switched to static types, or maybe. And everyone has their biases. And when I try to argue this kind of stuff, people argue, you know, what you say is a pro and con. No. There's no cons to dynamic typing. There's no cons to static typing. Only pros. So I'll start by kind of sharing my own biases by telling you in a few minutes my own long path along programming languages and features. So this is me. And I was fortunate to be exposed to programming at the time when learning programming was feasible. And it was wonderful. And I really wanted to make computer games, but, and I learned BASIC. And the games I made were kind of crappy, like you ran games in the computer and there were smooth animations. And I couldn't make that. And that wasn't due to my lack of understanding in BASIC, that was because BASIC was a toy language. And real games were made with assembly or C. And again, I was fortunate that my mom arranged for me and my friend Liat to learn C from a tutor, which was a kid in high school who knew C. And with C, I could make real video games. You know, maybe the artwork was crappy, but technically they were real video games. And this was my thought at the time. BASIC is a toy language, it's interpreted, C is the real thing, it's typed, it's much more difficult. And it's much more difficult because you can have buffer overruns, you can have double free. It's easy to get to a corrupted state, which would be really hard to debug. And in BASIC, you can't have these types of errors that you spend a lot of time debugging. And then I also learned C++ and started to work in industry with that. Pretty much the same, but nicer. Name spacing, etc. And then I turned 18, where I come from in Israel. people are usually drafted to the military. So from C++ with its discipline of being careful from overruns, I came to the military. Then again, I was fortunate that there they taught us Python. Okay. And it changed my mind about what real programming is, because even though it was more like basic in terms of things are running slow and you're safe, it was real programming because that was what they wanted us to use for real things. And then I had like a vision of, okay, Python is high-level programming. That means dynamic typing and garbage collection, that you're safe. And high-level programming is not suitable for everything. And in C++, where you use heavy design patterns, in Python you just have first-order functions, you have reflection. So sometimes you still use C, but generally Python was my favorite language for a long time. And then in 2005, I saw Jonathan's subtext demos and rants, and kind of opened my mind asking questions. Does this distinction has to be like this? One point I want to say about this, to be sure now, this guy didn't know it, but correlation doesn't imply causation. So dynamic typing doesn't necessarily not necessarily all high-level programming languages have dynamic typing. So now I'll get to some thoughts I learned since then. We tried to make a projectional editor in Python for C. And that kind of showed us the limits of using dynamic typing. And also following subtext demos, we kind of find that Haskell had a similar I/O model to the early subtext videos. And Haskell has static typing and type inference. And we learned that static types are useful not just for performance. Like a traffic light, it could be a bit annoying to wait with it for a long time, but it can save us from crashes. And ways can guide us to the right path more easily than having to remember everything the way by heart. Also, the concept of type inference available in languages like Haskell. The computer doesn't have to be that dumb that I have to tell it all the types of everything like C++, Java. And the key point is that programming is an interactive process, and where the computer, it doesn't have to be, I write a big text file, give it to the compiler, and it tells me I can either figure out what you mean or not. It's an interactive process, and the editor can help us more there. And from that, before we go on to discussing the pros and cons of static typing, I want to show you a small demo. So this is Lambda. And it's a projectional editor. And what I see here is I'm calling the sum of filter of one dot dot something, a whole. And a filter, I have a font, it gets an argument keep, which is a lambda, maps a number to something. And by default, if I wanted, I could see the types of everything. But by default, I see the types for holes, which is useful. It's what I'm going to fill. It will be useful content. So let's type the filter. Let's see what is the sum of numbers that are multiples of 3. So I write num. This could be improved. It's kind of looks like what's called dark version 1. But you know, it's also we're cutting features, and we'll get there. Okay. So if I just choose none, I'll show you what I have here. It's wrapped in this red rectangle. We call this a fragment. It should be a rule, but it's a number. Or if I do none modulo 3 equals 0, now it's not in a fragment anymore. It's good. And if I 1000, it runs. And I can see this was called with different inputs, and I get the result. And what we use, small technical issue, don't buy this new. Okay. Someone have an external keyboard? Okay. Okay. So the way we show the values, unlike Python show, we don't just show the last result, and we don't just show the result when the cursor on it is on it. We show a result under everything. If anyone is familiar with Brett Victor's essay, Magic Ink, he argues that too much interactivity is not good. And it's easier to just hover with my eyes instead of having to move the cursor. Of course, this is pretty verbose, so I can switch to seeing the code in a cleaner way. Okay, now I'll go back to where we had before. Okay, I'll go back to here. So the idea about this fragment is whenever I type something that in a textual language would cause a type error, it is wrapped in a fragment instead. Okay, so type inference always works. Types are always valid. It's just that this thing is not directly here. It's wrapped in a fragment. And the fragment is a barrier for the type inference. Go on. And this isn't new. We showed it in the future programming workshop in Splash 5 years ago. And since then, it was also adopted by Hazel. And I'll show one more thing, a simple example. Let's have an if statement with that piece of text here, and I type a number. Now, in the textual programming language, either of these would have been the one getting the blame for the typers. Over here, the behavior is as follows. The newer one, which contradicts the previous programmer input, gets assigned the typer. And the point of it is that this environment tries to give you a lot of feedback. And I should be pretty happy about what I have so far. Now, if I really want the num to be the right type, I have a hotkey for that. And it says, okay, move the error somewhere else. So this is the basic experience. It's not everything. I'll show the rest later. And I'll go back to discussing some pros and cons and what we're trying to achieve here. So here's a quick comparison. There's a lot of stuff here between dynamic types and static types, either explicit or inferred. And the overall message of this is that each approach has its benefits. Okay, so with dynamic typing, I can run a program even though it's incomplete. Even though somewhere I have an error, I can run it. I can run the branches that have no errors. Now, I'm not saying you have to deploy code with type errors to production, but it's nice to have the option to be able to run it in your repo, right? But with static types, I have a lot of static checking that people, I don't know if anyone had the experience of deploying something to production in Python and getting your service to crash in production, and you have to stay up late to fix it. So you don't get that as much with static languages. And the performance is better. You also get, like we saw in Dart, type-assisted editing, even though it was solely based on static typing, but you get it not only when your code is run. I can create a function. I don't have inputs for it yet, or I'm in a branch that doesn't currently get executed. I still get type-assisted editing. I still get completions that are related to other. Now, a big problem with explicit static typing, like in Java or C++, is that it's really verbose when compared to Python, which is delightfully concise. With inferred languages, it can also be concise, but the writer may choose to add some types because they kind of help readability or help communication. Now, explicit types have a benefit over inferred types in that the errors only propagate, like, they don't go and propagate far. I say the type for everything. If it doesn't fit, they don't get type error far away. If someone used C++ templates, you can make a change somewhere, and you'll get the error somewhere completely unrelated, and it's going to be a very, very complicated error. If C++ templates were statically typed, explicitly statically typed, wouldn't really happen as much. Or, yeah, let's say Java generics. So now I'm going to start comparing the steady typing approach. So as we saw, code, here I'm saying I get the completions only when the code is valid. In Lambda, the code is always valid. Type inference always work. So I get this. And I'll just show you how a demo of how it runs despite of errors. So here I made a function called favorites, and let me enable the evaluation. Right. So this is a really simple function enumerating favorite things, if you know the song. And it has a type mismatch over here, but I can still run it. You give it the input 0, I got the result. If I give it the input 2, now it got to the place with the type mismatch. I can jump right into it, and this place basically has an invalid type. But as long as I'm executing code path that has no errors, I can run. So I get this benefit that I can still run some code despite of having an incomplete code base. And the UX for the errors, it's much friendlier than here and here. I get in place the fragment that tells me what the type is, what it should be, and I get it there because I'm in the context of editing there. I don't get it somewhere else. If it's complicated for me and I say, no, this is the right type, I have a hotkey, move it somewhere else. It's really clear why that somewhere else contradicted what I just did. And yeah, and it doesn't get propagated far unless I manually push it. So I don't get this problem with type inserts. Now I'm going to add a row here. Okay. This is kind of like the basic stuff, and the row is when I have a big program and I do a change, maybe I add a parameter to a function that is used in other places. Like, how does that work? So in dynamic typing, you better have a really good test suite that would catch all my usages of the function with changes. Otherwise, I'm going to miss something, and it's going to crash. With explicit static typing, the experience, I'll argue, it's pretty good. The compiler tells me all the places I need to fix. With inferred, my color resolution here is not so large. I put it as red, but maybe it should be like orange. With inferred static typing, the compiler helps me, but it may give me the errors in weird places, and I won't really figure out what happened. And if I change a function, maybe it's okay, but if I update a version of a library that has some changes, I may not understand what's going on. Still better than missing places like in dynamic language. Now let me show you how it works like in that. So I have prepared this function, some digits, right? And this is how the function looks like. Calls the sum, and it calls the digits function, and this is the digits function. So it got 2, 3, 4, 5. It doesn't equal 0, so it got to this branch and it took the first digit and it const it to digits running on the rest of it, and basically this is the trace of what happened. Now let's change it to be this verbose, because when I edit code, I actually prefer to see it like this here, and it looks like Python. And let's add a base argument to digits. So I add a base parameter, right? And I'm going to change this to not be modulo 10, it will be modulo base. And here I'll give base, and here change this to base. And okay, let's try to run this. It doesn't run because a dependency type needs up. What does this mean? Sum of digits uses digits. And as a rule, we want the code to always be valid in some sense. In this case, the sense that the types are always valid, type concurrence always succeeds. So what goes on is the sum of digits in the database for itself, it had the types of its dependencies saved. So it knows what was the type of digits when I wrote this function. And the type of digits has changed. And updating this dependency is kind of like an action. I show the user the dependency has changed. So they have a really good sense of what is going on. So it was num to a list of num, now it gets 2 arguments. So I just click the update 2. And now it changed the parameter name from num to rect. That is because it didn't name this parameter. But let's say I named it x, now it wouldn't change it. So it automatically chose a name for the parameter, and because it was a number, it called it num. But basically, I want to not give it x as a record of parameters. I want to make a record to add a base, which is 10. And it still works. Okay? Yeah. So in order to make the experience clear and not have wild propagation of type information, at each point we're saving the types of the dependencies. And we let you see it was that, it changed to that. And in the future, we may also have automatic migrations you could apply if you change something in an API and you have a default argument. And we'll basically switch to questions. Yes.
Thanks, that was really interesting. I was wondering, in the earlier example, you had something where you said there was an else branch where a type error occurred, and you had to open the function before you could see it. I'm not sure which one it was, though.
So here.
Oh, no, that was in between somewhere, and you had you could run it despite the type error. Yes, that was that one. Although it was there, and you only got an error when you run it. And
no, the fragment, you can say it represents the type error.
Yes, so but you don't see it. This is
right. We should add a panel that lets you jump to all the errors.
Yeah.
You know, we're basically 2 crazy guys developing it on a free time. It's an open source project. If you want to help us and add the error panel, like it will be available. The idea isn't to hide away the errors. It's just not ready.
What's your roadmap? What's coming?
Okay, so the roadmap is that I have to make this into something I actually use. And other than this, they have a company doing audio effects for mixing music and film. So I have to make this at least ready maybe for real-time DSP code, but the idea is it's general purpose. We don't yet recommend to use it, even though I made a simple website using it. Which you can do. It has a lot of missing features compared to other languages, like Haskell. We want to add the type classes if you're familiar. We have some things that you wouldn't currently want to use the language as it is. So the roadmap is to complete it, and we're slowly working on that. And we're looking for contributors and collaborators. There's a lot of interesting things to write about that hasn't been presented. That's just like not a deck. Like for example, the responsive UI that makes sure you don't have to do the horrible horizontal scroll, and also switching to different languages, natural languages, so people who don't know English can still code on the same code base. But yeah, it's a really big project, and we already presented a version of it 5 years ago in the Future Programming Workshop, but it advanced since then. And also one thing I would want to have is kind of bring end user programming into it. So for example, if currently I edit a video in a video editing program like Final Cut, I hope to switch to this, where currently applications have kind of what they provide, but a lot of times it's annoying.
Yeah, so one of the things I really like about this is the way the fragments are kind of like a way of associating type errors with edits. Is that fair characterization? So if I type in a bit of code and it's kind of locally L types, because there's a requirement coming in from the context that it has one type and I type something that has a different type. So that, in a sense, associates type error with that change that we made to the program.
Yeah, the error you can say is changed.
So I'm wondering if you thought about, I mean, is there any kind of versioning? I mean, it looked like you were going back and
so currently there's a really limited version control. I can switch to a different branch over here. What is it up for creating a new one? Never mind. There is a limited version control with no merge. We would like, when we implement merge, to make it aware of the types. So changes that may currently yield no conflict in Java, then you get a compiler error. We want to better integrate it. We haven't gotten that.
How does your code look like in this?
So there's a database. It's using Live2019. So it's a Live2019 database, like special format. For ease of sharing code, we have like a JSON-based export format, and we also implemented migrations on that and made breaking changes on the language.
So do you base on it, I assume, in the master?
No. We'll have to reinvent version control.
Yay. The most important question is there a dark mode?
Oh yeah. Yeah, there's a dark mode. There's also a retro mode with fixed.
Nice. All right, thank you very much, Eric. Okay, we're on break until 11. And